Welcome to NIOP Chemistry. Hello students, how are you? I hope you are all fine at home. Okay, in previous video you have learned about elements, compounds, definitions and some of the basic properties of elements are discussed, and some element uses also I mentioned in previous video. In this video you are going to know about detailed account of compounds with its properties. Okay, let's start today's topic. And here I wrote some properties of compound. So one by one properties we can check taking some examples. So before going to start the properties of compound, let us see once again the definition of compound. Compound is a pure substance which is formed by two or more elements combined chemically in a definite proportion. So compound is a substance formed from two or more elements combined chemically in a definite proportion, and this compound have some properties. So those properties are listed here one by one. Let us check. First one, it's a pure substance. No doubt of it. It's a pure substance. Only one kind of units are present. Unit means here we'll take a molecule. One kind of molecule only present in this substance. There is no any other type of molecule present along with the unit of that compound substance. For example, if you take 100% pure water, so it is distilled water. In the distilled water, there we find no solid substance or no gaseous matter and no any other ingredients present in that water. That much pure water, we call it as a compound substance. Understand? Okay. And it is homogeneous. How can we understand the homogeneous nature? Take one bucket of water and from top layers collect one sample, 100 ml of water. Take and again 100 ml of water from middle layers and take 100 ml of water from bottom layers. Now count the number of particles present per unit volume, and that unit amount of water shows the exact number of molecules present in different layers. You might have collected that volume of water or the mass of water from different layers, no matter, but it contains equal number of particles of water. So it's clear that the water particles are distributed at equal distances. So any layer of the substance we may take, it contains the equal number of particles. It shows the homogeneity of that compound substance. The next one, definite set of properties. Likewise, again you take a bucket of water, collect 3 samples from 3 different layers, top layer, middle layer and bottom layers of water. Now test the melting point and boiling point of these 3 samples of water that were collected from different layers of the water. You will find the water will have melting point or freezing point at 0 degrees Celsius and boiling point at 100 degrees Celsius. For 3 samples, not for single or not for 2 samples, and it is for 3 samples. So it's clear in 3 samples they have the same properties. Melting point and boiling point, both are same for these 3 samples. So it's clear that the substance has definite set of properties, no matter the layer of the substance from where we are taking the sample for testing. Each and every corner of that substance will have the same properties. Okay, next one, cannot be separated by physical method. Okay, water is there. Water is a compound. Let me write formula. Here, water, hydrogen and oxygen react to form water. Water contains hydrogen and oxygen. Hydrogen and oxygen present in the compound. Chemically they combine. How can we separate? Okay, here physical process. Let's see some techniques one by one. So, by heating water, if we heat, what do you notice? After some time it will start to get heat. After heating, it will start to evaporate. Do you think that water is separating into gaseous state matter of hydrogen and oxygen? Because water is formed from two gases, hydrogen and oxygen only now. So some of you may get such an idea. If you got that type of idea, well and good. If you are not getting also, no problem. Anyhow, you just imagine water is formed from hydrogen gas and oxygen gas. Understand? So when we heat the water, it evaporates. Again, gaseous form of the substance will rise up from the liquid. Don't think that vapors is of the form hydrogen and oxygen gas. No, it is not separated. Only the water molecules are separating, or they are just transforming from liquid state to gaseous state. Only that. What particles you have noticed in its liquid state, the same type of particles again you will see in that vapor state also. So heating is a physical process which is not suitable for separating hydrogen and oxygen from water. Then how can we separate? See here. Can be separated by chemical process. What is that chemical process? Here, electrolysis is the process generally we use. Okay, let me write the chemical equation concern that separation of water using electrolysis process. Here it is water, H2O, separated to its constituents hydrogen and oxygen. Electrolysis. In this process, electricity allowed to pass through this water. Then water separated into its constituent elements hydrogen and oxygen. Do you think that by the passage of electricity through this water is possible to split water into its constituent elements hydrogen and oxygen? No. Only if we allow this water, even electricity also won't pass through it. Because pure water is poor conductor of electricity. If there is no conductance in that substance, then it is not possible to separate the constituents. Then here it is required chemical process. That means some chemical we need to add. Maybe it is a strong acid, that is H2SO4 or NaOH. To this water we need to add some chemical substance. That chemical substance is strong acid or strong base. After adding, or even sometimes we can use salt also. Instead of this acid or base you can use salt, which is soluble in water. So after adding these chemicals, if we allow the passage of electricity through that, water can be separated into respective constituents hydrogen and oxygen. So it is possible with the help of chemical process. The next one, compound properties are different from the properties of elements from which it is formed. Okay, let us take another example. How can we understand See here, this is a very good example to understand how compound properties are different from the elements properties from which the compound is formed. Here these are the two elements, sodium and chlorine are the two elements, and from these two elements the compound sodium chloride is formed. Now, how the formed compound substance sodium chloride properties are different from the properties of sodium and the properties of chlorine. Let us see first the properties of sodium. Sodium is an explosive metal which is very dangerous, highly reactive. If any water come into contact with this sodium, it will explode out. That is the nature of sodium. We cannot eat. If someone try to put a piece of sodium into any water, immediately it will explode. So we cannot eat sodium in its elementary state. That is the property of sodium. The next one, chlorine. Chlorine is greenish yellow gas which is a very deadly poisonous gas. Once if we inhale this gas, person will die. That is the nature of chlorine gas. But when this explosive metal sodium and poisonous non-metal chlorine combined chemically, they form a flavored substance sodium chloride, which we are eating and which we are adding to store some pickles or some meat as a preservative substance also, which giving taste for the food items. See how the properties of compound sodium chloride are different from the elements from which it is formed. Sodium is explosive, chlorine is poisonous, and when these two elements combine chemically, both are forming a new substance. The formed new substance has its own properties. You see, the formed substance contain sodium atom and the formed substance contain chlorine atom also. Even though sodium and chlorine are present in the formed substance, the formed substance is not showing the properties of sodium, and the formed substance not showing the properties of chlorine. It has its own properties. Okay students, now this is the time for knowing about mixtures. What are mixtures? How these mixtures are made up of? What things makes up these mixtures? How can we understand? How compounds are formed from the basic materials. Likewise, here mixtures are formed of different combinations. The basic materials, element and element may combine to form a mixture, or element and a compound, they may combine to form a mixture, or sometimes compound and a compound even they combine to form a mixture. Here I am using the word combine. Don't think that combine means it is not stands for chemical combination. When here for the formation of mixture also the substances are combining, but they are just interacting with each other, having no chemical forces acting between the particles that are present in the mixture. So let us see the definition of mixture. Mixtures are impure substances, yes, no doubt of it, and whatever the number of components we may take, those all components they just combine in any proportion, indefinite ratios of proportions we may see between these components. Okay, using two properties I mentioned here mainly. One is indefinite ratio, and second one is absence of chemical forces. So using these two properties we can give definition for mixture. Okay, see, mixtures are impure substances which are formed by the combination of two or more components in indefinite ratio, and they're acting no chemical forces between the components. Enough. Let us see some examples in our day-to-day life activities, and whatever the substances we are using at our home. The main mixtures or eatables. Yes, I think you will prefer for having these mixtures. You are not taking any compound, you are not taking any element substance. Always, each and everyone, those who are living on this earth, they are taking mixtures only, not elements and not compounds. Okay, come to the point. Here, first one is eatable. Whatever you are taking from your table is completely a mixture. Maybe it contains compounds or elements, it's not the matter, but whole as a substance what you are taking is a mixture, no doubt of it. Some pulses, some grains, and different ingredients you may see while taking those mixtures. Even in curry, different items will add. Different items will add. It's a mixture. Anyhow, some chemical reactions also may take place. That is another thing. Then next example is soft drinks. Do you know what is soft drink? Soft drink is very easy to prepare. If you have a cylinder containing carbon dioxide and a gas pressurizer. So here, while making soft drinks, we take some water, mixing it with sugar water only we are taking. Into this sugar water, some flavors, whatever the flavor, orange flavor or green flavor or apple, what different flavors we can add. Whatever the substance we may add, it gives that flavor. And next, color. What color you like, that color you can add to it. Grape color or orange color or lemon, white, snow color. So different colors, red color, green color also available. So different colors, whatever we may add, that just shows its property in its individual state. The next, finally, we are pressurizing carbon dioxide gas into that water, colored water or colored sugar water or colored sugar flavored water. We are pressurizing carbon dioxide gas into it. Then finally you will have the soft drink. Now soft drink is ready. This is the way of making soft drink. Only just ingredients we are mixing. They are showing their properties. And milk, another example. In this milk, water is present, carbohydrates, and some sugars, some proteins, some vitamins. So different ingredients are present in this milk. If you collect a milk from one company to another company, taste will vary. If you collect this milk from different sources, I mean buffaloes are some sources, cows are another sources, even from buffalo to another buffalo or cow to another cow. So among these animals also some variations are there. So the ingredients present in that milk is varying. Okay, next another example, and a very good example is honey. You people are aware of this, you might have used this honey, and it is very sweet in taste. Generally they use for children for better growth. The reason it will supply maximum ingredients that required for the growth of children. Now this honey we are getting from honeycomb. So the collected honey from one honeycomb is different from the honey that was collected from another honeycomb. Why this variation is? Reason: honeybees are visiting a number of plants. That means they are visiting a number of flowers. Nearly 3000 plus flowers they are visiting. So in this visiting, they may visit number of times a particular flowers, or they may collect maximum substance from that flowers, honey. So it is showing such variations. Definitely it will comes under a mixture. Somebody may think that we are taking pure honey. Pure honey it does not mean that it's a compound. Pure honey generally people use for directly they are collecting it from honeycomb, and they are not adding any other like water or any other liquid of sugar solution or any jaggery solution into it. People will mix up some ingredients. So whenever they find directly collected honey from that honeycomb, people say that is. So these are the examples enough for you to make you understand what are the mixtures and how the ingredients are showing their properties. Okay, finally I am going to mention the important thing which will help you to understand the different types of mixtures. In a mixture, what number of components are present, those all components shows their properties. For example, sugar, salt, lemon, water you take. If you mix this sugar, salt and water and adding lemon juice, you will experience the taste of sugar, taste of salt and the taste of lemon juice at once. At a time you are experiencing these three types of taste. That means it is not a compound and it is a mixture. So you are able to taste that three, or if more substances you add, definitely you will experience it. That is a mixture. So finally it is a mixture in which the ingredients present shows their individual properties, and is possible to separate the ingredients, components, to separate them from one another. It is enough to use physical techniques. By using physical process, we are able to separate the components from the mixtures. Here different types of mixtures are listed. How these different types of mixtures are formed? How can we understand the types of mixtures? By what property these types of mixtures are possible to form? Only one property I am going to put in front of you, that is state of the matter. Yes, here solid, liquid, gas. These are the three states of matter. And solid, when it is combined with another solid, solid combined with liquid, mixed up with solid or liquid, or when the solid mixed up with gas. Likewise, different combinations I have written on this board. Let us see one by one with examples. First one, solid in solid. Solid substance must be present in another solid. How it is possible? How can we understand this? Solid in solid, solid in liquid, solid in gas. That means only simple. water is taken in bucket. Okay, see, how can we say water of bucket or bucket of water? Here water is in bucket or bucket is in water? Water in bucket, not bucket in water. So likewise, take one glass of water. In that water add some sugar. Now sugar in water, not water in sugar. So here you need to pay much attention to understand these types of mixtures. Okay students, come to the point. Solid in solid, that means one solid is present in another solid. See here an example, alloys. Alloy means mixture of metals. Steel, stainless steel or steel bars that we use for constructions of buildings or any bridges. The next one, eatables. Some eatable mixtures also available in some shops. You will buy and eat that eatables. You are familiar with these eatables. So these are the good examples of solids in another solids. Maybe the solid and solid or whatever the type of mixtures I have written on this board, either of the types, again homogeneous or heterogeneous. Then solid in liquid, just I mentioned sugar in water, that means solid particles of sugar or solid particles of salt in water. Then solid in liquid we say. Likewise solid in gas. See atmospheric air. In that atmospheric air, when smoke is released, smoke is containing actually unburnt particles of some substances. Then these unburnt particles of solid particles are present in atmospheric air. So solid particles in gas. Atmospheric air is a mixture of gases. In that gases again these solid particles are present. The next, liquid in solid. So here best example, amalgam. Amalgam means liquid state of metal. Mercury is present in solid state of metals which we use for filling tooth cavities. That is amalgam, and even this amalgam we use as a catalyst in some chemical reactions. The next one, liquid in liquid. This is a well known and best example. Liquid in liquid. Take milk and water. Both are in liquid state. Milk is in liquid state, water is in liquid state. Just mix them. Then you will have a mixture of milk and water, and even different kinds of oils. Oil in oil or oil in water. That means maybe they may form homogeneous or heterogeneous, that is another thing. Just try to prepare a mixture, liquid and liquid type. The next, liquid in gas. Again here, liquid in gas. Atmospheric air contains water droplets. Water vapor is present in atmospheric air. Do you know that? Water vapor is present in atmospheric air. So water droplets, clouds, convert into tiny water droplets. They are present in gaseous matter of air. So that is an example. The next, gas in solid. Gas in solid. How can I make you to understand this gas in solid? So sponge. Okay, let me show you an example. Here it is a sponge. This is a solid material, and some spaces are there. Some spaces are there for this solid, and it trapped some air into it. Some air was trapped into this sponge. So another example, gas masks. In wars, soldiers will use some masks that protects them from poisonous gases. That means these gas masks are absorbing the gases. So now gas in solid. That is another example can understand. The next, gas in liquid. Soft drinks, a very good example. Soft drinks, cola, Pepsi or Sprite, any other soft drinks, they contain or they are pressurized of carbon dioxide gas into them. That is an example of gas in liquid. The next one, gas in gas. Atmospheric air is a very best example for mixture of gases. Gas in gas. So different types of gaseous materials are present in atmospheric air. Nitrogen, oxygen, carbon dioxide, another gas, water vapor, gaseous state of them, and some other gases that were released from factories and industries and vehicles are also mixing up with this atmospheric air. So atmospheric air we can take as an example. Okay students, these are the different types of mixtures and some examples I mentioned here. How can mixture be distinguished from a compound? Mixtures can be separated from one another components by applying physical techniques, whereas compound cannot be separated by applying a physical technique. Only a chemical technique can be applied for this compound substance to separate their components. Topics. Thanks for watching this video.